Okay, for this question, we know that we've got these two seesaws that are joined and Robert's standing in the middle. So we're given some of the distances and they're telling us here that Poppy is a weight of P, so she's PG newtons, going in that direction, and Quentin has a weight of Q, so he's QG newtons. And we know that Robert has a mass of 80, but we don't know how he's distributing that mass. He's kind of got 1 foot on this seesaw and 1 on this. So he's distributing it between the two seesaws to keep them balanced. So let's say on this one with Poppy, he's putting AG newtons, and on this side, he's putting BG newtons. So let's just look at this seesaw on the left. So if that's an equilibrium, it's not moving, so clockwise moments equal anti-clockwise moments. So its clockwise moments will be 2 times AG, and its anti-clockwise moments will be 3 times PG. So we could say 2AG equals 3PG. We could divide both sides by G, and say 2A equals 3P. If we look on that side and do the same, clockwise moments would be 3QG equals anti-clockwise moments, which is 2BG, and divide by the G's, we've got 3Q equals 2B. Now we know that here the total weight, what he weighs, is 80. So A plus B must be 80. So that's what I know as another part of the question. And I'm asked about working out what P add Q would be. If I notice here, I've got these two things. So if A add B is 80, if I look at this equation, I've got 2A equals 3P, and I've got 2B equals 3Q. So I could say, well, if I combine those together, I know then that 2A plus 2B must be 3P plus 3Q. And if A add B, I've just set up here is 80, and that must be 2 times 80 equals 3 times P plus Q. 2 80s are 160 equals 3 P plus Q. And then if I divide by 3, I get P plus Q equals 160 divided by 3 is 53.3 recurring. But it just says show that it's equal to this to the nearest whole number. So to the nearest whole number, P plus Q must be 53.